This is the first question. It says the number of zeros of the polynomial y equal to p of x in the given graph is. So we have to find the number of zeros of the polynomial y equal to p of x. So y equal to p of x is nothing but it is the graph. This graph line is called as the y equal to p of x. So the number of zeros, which is nothing but equal to the number of times this graph cuts the x-axis. So from the figure we can see that it cuts this x-axis here one time, here two time, and here third time. So this graph cuts the x-axis for 3 times. Therefore the number of zeros of the polynomial is nothing but 3. Second question. For an event E, if P of E equal to 0.75, then P dash of E is. So, the possibilities of occurring this event is 0.75, and we have to find the possibilities of not occurring this event. So, we should know the formula, that is P of E plus P dash of E equal to 1. So, it is given that P of E is 0.75 and P dash of E we have to find, so which is equal to 1. P dash of equal to 1 minus 0.75, which is equal to 0.25. So the correct answer is option B. Next, this is third question. It says that the total surface area of a right circular cylinder having radius r and height h is. So we have to find the total surface area. If we know the formula, then we can directly take as 2 pi r equal to r plus h. Otherwise, so to find the total surface area of a right circular cylinder, we must know that we have to add this curved surface of the cylinder and the surface area of this both circle. This is a cylinder and this is a circle on both the sides. If we add the surface area of this curved area and these two circles, we will get the total surface area. So the formula for the curved surface area is nothing but 2 pi RH, and the formula for the surface area of both the circle is, for one circle is pi r square. As we have two circles here, so it is nothing but 2 pi r square. So 2 pi RH plus 2 pi r square, we have to take a common because we don't have a direct like this over here options. So if we take 2 common, pi common and r common, we will be left with here h and here 1 r. So h plus r, 2 pi r into h plus r. So the correct option is D. So here goes the next question, which says the number that represents the remainder when 19 equal to 6 into 3 plus 1 is compared with Euclid's division lemma a equal to bq plus r is. So the question says we have to compare this number with the Euclid's division lemma, that is a equal to bq plus r. So as it is told to compare, we can just compare. So here in the place of a it is 19, in the place of b it is 6, in the place of q it is 3, and in the place of r it is 1. We have to find remainder. So here r is the remainder. So we get the answer as 1. The correct option is C. 1. In the given figure, PB is a tangent drawn at the point A to the circle with center O. If triangle AOP equal to 45 degree, then the measure of OPA. So it is given in the figure that this PB, it is a tangent to a circle at a point A. So it touches the circle at a point A. And it is given that if triangle AOP equal to 45 degree, the triangle AOP is equal to 45 degree, we have to find OPA. We have to find this angle. So whenever we have to find the angle inside the triangle, we should know one formula, that is the addition of these three angles is always equal to 180 degree. angle O plus angle A plus angle P is always equal to 180 degree. Now angle O is nothing but 45 degree. Angle A, so we can observe that it is a right angle triangle. If you don't know any angle, first search that is it right angle triangle. If not, apply this formula. Yes, we can say that it is a right angle triangle. So right angle triangle is nothing but 90 degree plus angle P equal to 180 degree. So 90 plus 45, 135 plus P equal to 180. Angle P equal to 180 minus 135, which is equal to 45 degree. So the correct option is A, 45 degree. The next question. In the figure, if DE is parallel to BC, then the correct relation among the following is. So in the figure, what they say, DE is parallel to BC. This is DE, this is BC. They both are parallel. Then the correct relation among the following is. So whenever you get a figure like this, where this base of the triangle is parallel to this line, then you should know the basic proportionality theorem. So what does the basic proportionality theorem says is, whenever these both are parallel, AD by DB is always equal to AE by EC. AD by DB is always equal to AE by EC. So that is itself asked here. We have asked this relation. So this is the relation that we have got. So correct option is C. The lines represented by the equations 4x plus 5y minus 10 equal to 0 and 8x plus 10y plus 20 equal to 0 are. So we have to find, is it intersecting lines, perpendicular lines to each other, coincident lines or parallel lines. Okay, so first of all let's write this both equations. So by seeing these equations we come to know that 4 2s are 8, 5 2s are 10 and 10 minus 2s are 20, right? So let's divide equation 1 by 2. This is equation 1, this is equation 2. 4 by 8, that's coefficient we are going to divide here. 4 by 8, 5 by 10 and minus 10 by 20. This is 1 by 2, 1 by 2, this is minus 1 by 2. These both are equal and which is not equal to this. It means A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2. Therefore, whenever this condition occurs, it is considered as a parallel lines. So this the distance of the point minus 8, 3 from the x-axis is. So most of the people do the mistake here is, as it is told as x-axis, they will take a x coordinate which is minus 8, but it is a wrong. So here, if we didn't understood any question, first draw it diagrammatically. So here the distance of the point minus 8, 3. So let's take a point minus 8, 3. This is y-axis minus 8. So from x, in the x-axis minus 8 is present over here and 3 which is present over here. So when we join that, we get a point minus 8, 3. The distance of the point minus 8, 3 is this from the x-axis. So from x-axis to this distance, then we have to move from x-axis to this point, which is this line is equal to this line, which is equal to 3 units. So the correct answer is 3 units.